I'm G Satvika from CSC C section. Today my topic is Autocycle working process and CI engine. Um, Coming to the introduction, the Otto cycle is a theoretical cycle for spark ignition engines. It was developed by Nicholas Otto in 1876. The cycle consists of four processes: intake, compression, combustion, and exhaust. And here is the diagram. Processes in Otto cycle all are mentioned here. And intake process. In the intake process, the piston moves down, drawing in the air-fuel mixture. The intake valve opens, allowing the mixture to enter the cylinder. The piston acts as a pump, creating a low-pressure area in the cylinder. And here we can see the explanation diagrams about this intake process. And next, compression process. The compression process begins as the intake valve closes. The piston moves up, compressing the air-fuel mixture. Compression raises the temperature and pressure of the mixture. And here is explanation about this. Next, coming to the combustion process. This is very important process in this. The spark plug ignites the compressed air-fuel mixture. The combustion process is rapid and creates a high pressure force on the piston. The expanding gases push the piston down, generating power. Exhaust process. The exhaust valve opens as the piston reaches the bottom of its stroke. The exhaust gases are expelled from the cylinder. The exhaust gases are expelled from the cylinder. They'll be in the cylinder and they'll be expelled from the cylinder. The piston moves up, pushing the remaining exhaust gases out of the cylinder. Next, differences between Otto and diesel cycles. In the Otto cycle, the air-fuel mixture is ignited by a spark plug, while in the diesel cycle, fuel self-ignites due to high pressure and temperature. Otto cycle engines are used in gasoline-powered vehicles, while diesel cycle engines are used in diesel-powered vehicles. The compression ratio in Otto cycle engines is lower than in diesel cycle engines. And here is the diagram about this. Uh, P2V and T2S diagram of Otto cycle. 1 to 2 is isentropic compression, 2 to 3 is constant volume heat addition, 3 to 4 isentropic expansion, 4 to 1 is constant volume heat rejection. Advantages of Otto cycle engines. Otto cycle engines have a higher power to weight ratio compared to diesel cycle engines. They are more efficient at higher speeds and lighter loads. Otto cycle engines have lower initial costs and are easier to maintain. Processes in Otto cycle. Uh, it power stroke adiabatic expansion, compression stroke adiabatic expansion, intake stroke, exhaust stroke. There are many strokes like this, and here's the graph and the diagram for this. Next, at disadvantages of Otto cycle engines. Otto cycle engines have lower thermal efficiency compared to diesel cycle engines. They consume more fuel for the same amount of power output. Otto cycle engines have lower thermal efficiency compared to diesel cycle engines. They consume more fuel for the same amount of power output. They produce higher levels of greenhouse gas emissions. Here are some graphs which explains that. And next, application of Otto cycle engines. Otto cycle engines are widely used in passenger cars, motorcycles, and small aircrafts. They are suitable for applications which frequent start-stop operations. Otto cycle engines are also used in power generators and lawn mowers. The future of Otto cycle engines. Research is focused on improving the efficiency of motorcycle engines. Advan- Advancements in direct injection technology and turbocharging are being implemented. Hybridization and electrification are also being explored to enhance efficiency. Conclusion. The autocycle is the basic for spark ignition engines. It consists of four processes: intake, compression, combustion, and exhaust. Autocycle engines have advantages and disadvantages compared to diesel cycle engines. Autocycle engines have advantages and disadvantages compared to engines. Thank you, ma'am.